Hey, Miss May, how's it going? Are you ready to learn today? Hey class, so today we are doing section 10.6, trig ratios. Our bell work today, we're looking at y equals the square root of x plus 3 and y equals the square root of x minus 2, and we're expected to graph the radical function. So remember from yesterday's lesson, x plus 3 means we're moving left 3 units. So we're taking the point 0, 0, shifting it over 3, up 1 over 1 to make our graph there. The next one, the negative 2 is outside of the radical, so that means that it's going down 2 units. So we're taking the point 0, 0, shifting down 2, up 1 over 1, and creating our graph. Again, from yesterday's lesson, it should make that shape every time, shooting star, right? And the lesson today will be on trig ratios. The sides of a right triangle can create 3 trig ratios. You will use this this year, Algebra 2, and a lot in geometry. We use these functions when dealing with right triangles. So the first thing we need to look at is, what is our reference angle? So our reference angle in this problem here is going to be looking from angle A. So again, this is called your reference angle. I knew that we were looking at reference angle A because it asked for the sine of A, the cosine of A, and the tan of A. Since it has a capital A, that is referring to angle A. Okay. Next thing we're going to look at are our 3 types of sides. The first one, the easiest one to remember, is always across from our 90-degree angle, and that is called a hypotenuse. So I'm going to go ahead and highlight that in green. Our next is going to be opposite of the angle. So if angle A is right here, straight on the opposite side over here will be our opposite. So I'm going to make that O, highlight it with blue. And our last one is going to be adjacent. Okay? Adjacent, we're going to put the A right here, and if you look, it's going to be right next to it. So right now, if I come over and I'm standing next to Miss May is adjacent to me. She's right next to me. Okay, so think the one right next to the angle is your adjacent angle. It is asking us to look at what sine, cosine of A, and tangent of A is. So if you heard Miss May earlier, she said SOHCAHTOA. SOHCAHTOA. These are our 3 different trig functions. Let's start with SO. S-O-H. If you look here, sine of A equals your opposite over your hypotenuse. So I'm going to write O over H. Our O was blue, so we would be taking the blue side over our hypotenuse, which will be green. Now class, if you were paying attention, I did not highlight the last one, so we're going to call the adjacent side yellow. The next one is our CAH, C-A-H. That stands for the C for cosine, the A stands for adjacent, the H stands for hypotenuse. So that is going to always be our A over H. Okay? So our adjacent side was the yellow over the hypotenuse, which again was our green side. The last one, our TOA, T-O-A. T stands for tangents, so the tangent of A, and O stands for opposite over adjacent. So that's going to be O over H. So our O was blue, and our adjacent was yellow.
Wouldn't that be an A then?
That would be, Miss May. Thanks for paying attention. So Class, these are the three trig functions that we're going to be using: sine, cosine, and tangent. Now, this is probably the first time you've seen this before, so Miss May, is there any other things that we should be reminding the class at this point that you can think of?
SOHCAHTOA.
SOHCAHTOA. Again, me and Miss May, even when we were in high school, back in the day, we were taught the same thing. When we took our quiz, when we took our test, that's the first thing we were writing down on it, right? Our teacher passed out our test. We wrote at the top of the test, SOHCAHTOA. Okay, so please do not forget that. Example 1. Find the sine of A, the cosine of A, and the tangent of A. Well, there's nothing there, right? So we gotta go ahead and label a couple of things. So the things that were given to us were, here is our angle A, C, and B. Okay? Since we were looking at the sine, cosine, and tangent of A, that means that this one here is going to be our reference angle. Reference angle just means what angle you're looking from, right? We're looking from this vantage point. The numbers that were given to us were 15, 17, and 8. Okay? So that would be what is going to be on the worksheet. That's going to be the problem that's given to you. What we need to do is try to look from reference angle A and label what types of sides those are compared to A. The easiest one is always across from the 90-degree angle. That is our hypotenuse, right? So we're going to put H. Again, as I told you earlier, if this is reference angle A, opposite of it, on the opposite side, it will be the 15. So starting from here, going all the way across onto the side there, that will be our opposite. And again, right now, I am adjacent to Kobe, right next to me, right? So right next to angle A, right here, right next to it, that will be our adjacent side. All right, so next we are going to write sine of A, cosine of A, and our tangent of A. You do not have to write this down, but if it is helpful, again, you can write your little acronym here. So sine of A is opposite over H, cosine A over H, and tangent opposite over adjacent, right? So that means our sine of A is going to be 15 over the hypotenuse, 17. Cosine of A is adjacent over a hypotenuse. Adjacent is 8 over hypotenuse is 17. And our last one is opposite over adjacent. So our opposite side is 15 over our adjacent is 8. That is all that you should be doing on this type of problem. Simply writing down the sides according to SOHCAHTOA, right? Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Miss May, anything, questions, comments, or concerns?
Nope.
All right, class, so go ahead and pause the video so that you can try the next practice problem, but let's go ahead and fill out what they gave us. So our triangle is still A, C, and B. Since they're asking for B, that makes that be our reference triangle, and the numbers that were given will be 8, 15, and 17. Okay, go ahead and try that. Ladies and gentlemen, pause the video. All right, class, so we were trying to find the sine of B, cosine of B, and tangent of B. So sine of B will equal, cosine of B will equal, tangent of B will equal. Remember, sine of B is opposite over hypotenuse, so we need to label these first. So if we're looking at B, this is still our hypotenuse because it's across from the 90-degree angle, but our opposite side will now be 8. And again, next to, right, the only thing that's next to this right here is your 15, so that's your adjacent side. So your opposite over your hypotenuse will be 8 over 17. Cosine is A and H, so A is 15 over H is still 17. And our last one for TOA is opposite over adjacent. So our opposite side is 8 over our adjacent side is 15. All right, class, if there's no other questions right now, let's go and flip to the other side. The next type of problem will ask you to find the cosine of 55. You will all like this a lot. It's just a calculator problem, okay? So here's your trig functions. We have sine, cosine, and tangent. This one here wants us to do the cosine of 55. So we hit cosine, we type in 55, close our parenthesis, and equal that, okay? Now, the problem says the nearest 10,000th, right? So, I'm going to write this number down first.
I got something different in my calculator.
What? What did we do wrong? Does anyone know what happened? I see it. See how that says RAD? That's radians. We need to switch your calculator. This is a great learning moment. Your calculator needs to be degrees. So, Miss May.
DRG at the top?
Huh?
Is it at the top, DRG?
See that? Left degree. Perfect. So let's try that one more time. So cosine of 55. Oh, Miss May, a different answer this time, right? Is this what you got this time?
That's what I got.
Beautiful. So we're going to scratch that out. 0.57357. Okay. For those of you that do not know your place values, 10,000th, this is 4 decimal places. So our tenths, hundredths, thousands, 10,000s. This is the one we should be circling. This is the number that we are looking at for rounding purposes. So our answer here needs to be 0.573. The 7 makes that become a 6. Okay? Again, we'll do the next practice one with you guys. Sine of 32. So sine of 32. Again, I'm double checking to make sure it's on degrees this time. And there we go. So we're going to write down 0.5299. And again, the next number was a 1, so that 9 will stay a 9. Miss May, any questions or concerns?
Easy calculator.
Nice. So enjoy that calculator one. Again, there's no work to be shown on that. Plug in your calculator, write it down on your homework. Next example, find the missing side length to the nearest tenth. This one's a little different now. We're given that we're looking at a 48-degree angle. We are given that this is called x, and this side length is 14. So Miss May, they didn't give me that problem. Do you think I need to worry about it if it's not given?
I don't think so.
I don't think so either. So it says find the missing side length. Missing is our x. What you guys should be doing, use the given angle as the reference angle. So again, we're looking from angle 48. Use the trig ratio that matches the two sides you have. Well, we haven't wrote down what sides we have yet, right? So always start with the hypotenuse. And again, this one is on the opposite side. So this is our A, adjacent, but again, we don't really care about it, okay? So Miss May, if we have O and H, what trig function? So, ka, or toa?
So, ka, toa, so.
So
O
what?
and H. Sine.
So, like that?
Yeah.
Perfect. We are looking at sine, okay? So we are going to now, again, use the trig ratio that matches the two sides, which we have done, and we're going to set it up with those two sides. So the sine of 48 degrees is equal to our opposite side, which is x, over our hypotenuse, which is 14. Okay, you cannot plug it into your calculator yet. Again, the goal here is to solve for that missing side. We're looking to get x by itself. So right now, x is to be divided by 14. The inverse of divide is to multiply both sides by 14, right? So we're now left with x equals 14 times the sine of 48 degrees. That is what we should be plugging into our calculator at this point. You could type it in just like you see it there. If you're afraid that this is not going to remember to multiply, you could put it in two parentheses. So parenthesis 14, parenthesis sine of 48. And we should be getting 10.40. Right here, you guys, it said the nearest tenth. So this is our tenths place. So we're looking here. That's going to stay a 4. So our answer will be x is equal to 10.4. Some of you, if you forget like Mr. Deshane almost did, if that happened to be in radians, does this make sense for an answer? Miss May, what do you know about the hypotenuse? Is it the shortest side or the longest side?
The longest side.
It is the longest side. So if the longest side is 14, would that make sense that that's a little bit shorter? Yes, it would. So that looks like a good answer. Okay, questions? All right, so class, go ahead and pause the video and we're gonna set up the practice problem, but let's go ahead and, all right class, so Miss May forgot to let me know you guys might wanna have the things on the triangle, so let's fill those out. So 22 degrees, this is our 10, and this is our missing side x. The other problem will be a 35 degrees. This is our x, and this is 20. Okay, before we continue on tonight's homework, which again is 10.6, Miss May and myself would like you at the top of your homework somewhere to actually write so ka toa. Okay, so please make sure that is on there. That way we know that you're watching the video. So first problem here. Here is our reference angle. This is an adjacent side. It's attached. That means that the longest side is what is not there. That's your hypotenuse. Again, we don't need that. And this one here from the angle will be our opposite side. So we're looking for something with O and A. That's right, it's TOA. So the tangent of 22 degrees is equal to my opposite side over my adjacent side. All right, Miss May, I'm gonna need some help. It's been a long day, right? I'm sure we've done all of our chores and we're really tired at this point, so let's try to do this one together. What should I do next, Miss May?
Ooh, multiply by 10.
Like that?
Yeah. Oh wait, that looks weird.
That does look weird. What's different about this one, Miss May, compared to our previous one?
X is on the bottom.
You're right. It's in our denominator. To multiply by 10 will make that become 100. We do not want to do that. So we got to get our x out of there. So instead of multiplying by 10, Miss May, we should multiply both sides by?
X?
That's right. We're going to multiply by x and x. Now, I know that looks weird to you guys, but let's see what this does. x tangent of 22 degrees is equal to now 10. Okay, so that's helpful, but x is still not by itself, right? We need this guy to be all by itself. Miss May, what are these two things doing right now if they're attached like this?
Ooh, they're multiplying.
That's right. So what is our inverse to get x by itself?
Dividing.
Correct. Again, what we're looking at now is that x is equal to 10 divided by tangent of 22 degrees. Use your calculator at this point. Again, we're going to hit 10 being divided by the tangent of 22 degrees. And you should be getting 24.75. Miss May, is that our answer? It did not say it in the instructions, right? But on our homework, it should be saying something like rounding to the 10th place. So again, our final answer will be x equals 24.8. Miss May, any questions? Does that look good?
Looks good.
All right, let's try the last one here then. So again, we are looking at our reference angle, 35 degrees. This is attached to it, so that's our adjacent side. And across from the 90-degree angle is our hypotenuse. We are missing our opposite side. Again, we don't need it for this problem. And if we're looking at A and H, we're going to be using cosine. So cosine of 35 degrees is equal to our adjacent over our hypotenuse. Tricky, right? This x is in our denominator again, so we got to do what we did on the last one. We're going to multiply both sides by x to give us x. Cosine of 35 degrees is equal to 20. And then we are going to divide by the cosine of 35 degrees. At this point, calculator, without a blur on that, right? Let's move that up. 20 divided by cosine of 35, 24.4. And again, let's think about this, folks. If this side was a length of 20, when we know that the hypotenuse is the longest side, does 24.4 make sense?
Yes.
Yes, it does. All right, class, we hope you're all doing well. We'll talk to you soon. Bye.